Good morning, everybody. Just as we have always been looking at different graphs having to do with the different types of functions and equations, we're going to do that same thing today. I hope that you have a really wonderful, blessed day, and let's just get going on this. Okay, so in our logarithmic functions, we talked about what logs mean. So 2 to the y power equals x. That's how that works. So we're trying to figure out 2 to what power equals 1 here. And that answer would be 0 because anything to the 0 power equals 1. 2 to the first power will equal 2, and 2 to the second power will equal 4. You can go ahead and throw those onto a graph and make your nice curve like we're used to doing. I want to think a little bit about the ones why it comes down here but it doesn't ever cross over the y-axis, because if we really think about it and we start thinking about, well, what about those other values? Okay, log base 2 of x equals y. What about for a half? Okay, 2 to the negative 1 power equals a half because 1 over 2 to the first power. 2 to the negative second power would be 1 over 2 squared, which would be 1/4. So we have this, it's kind of thinking backwards on those things. So the 1/4 would be down at negative 2. And then it would go on and on and on, kind of like exponentially downward, if that makes sense, towards the y-axis for the logarithm. It's just backwards. In other words, it's an inverse of your exponential function. So increasing this way and then coming down here, but instead of having the x-axis being the place where it's approaching but not crossing over, we have the y-axis, the place where it's crossing over. Remember our inverse functions, if you think about this imaginary line, it's just the inverse. In other words, you could fold the paper over and you would get the same thing on both sides. Okay, so just like any of the other types of functions, these can be moved up, down, left, right. So we want to talk about that a little bit. They follow the same rules. They can be transformed, but you have to think about what goes where. So if you have a 1 that's hanging out on the outside that's not really attached to the original parent function, then this is your up and down piece. If you have it that's attached to the x so that the logarithm is applied to it, this is your right and left indication. So make sure that you write that down so that you have the h and k in play, just like we had in the other things. Okay, so for example, this one, the whole function is going to move up, so point for point moving up. I'm not choosing to do the compressions and stretches here, okay, but if we were, that would be a number out in the front here and it would be compressed or stretched. Focusing more on you being able to recognize what it can do rather than the precise graphs on these things, because you're really just applying the one thing to the next thing to the next thing, and this would apply to all types of graphs. So this one's going to move it up 1, and this one is going to move it right 2. And here's basically what that looks like. Here's your original, right, all the points are right 2 for this one, and all the points are up 1 for this one. Okay, so same rules that we've been doing all year. Okay, so that means that when you go through, if you're asked to describe the transformations and not necessarily produce a graph, you just look at what it's doing, just like we've been doing all year, and you analyze what's happening with these different changes to your basic log base 2 function. So here, we've got the 7 hanging out outside here. I think you should probably try to anticipate the answers before I say them. Okay, this one will tell you to go down 7. This one will tell you right 3. This one will tell you left 4. And this will tell you left 1 and down 7. And these are the type of things that I would be expecting you to know for any quizzes or tests coming up, to be able to describe what kind of transformations for those functions, just like we've been doing all year. Hopefully this is the easy part. Okay. Inverses. Okay, the whole title of this section is Logarithmic Functions as Inverses. So we want to actually think about the inverse, and when we remember when we were trying to find inverses, we switch the x's and y's. So in this case, if we switch the x and y, here's your x, here's your y, log base 6, that's the same thing. And then you remember your job was to solve for y, but we can just use rewriting this in order to solve for y here. This is really 6 to the xth power equals y. Okay, 6 to the x power equals y. It's solved for y, and there's your inverse function right there. Notice that this happens to be an exponential function. Okay, it happens to be an exponential function. If you were going to graph it, you would have a y-intercept of 1, and it would increase exponentially. It would be, and you would have that, just to review on those things. So you switch the x's and y's, and then you've got that. So once again, on this one, we need to switch your x's and your y's, and then solve for x. This one has a little bit, slightly more to do with it, but not too much. Because once we've switched, here's your y, switch to an x, and here's your x, switch to a y. You have a base of 3, so 3 to the x power equals this. 3 to the x power equals this. Then it's just a matter of subtracting the 5. And when you've subtracted the 5, you have y equals 3 to the x minus 5, and that's your inverse. Remember, inverse is always just switch the values and solve, but now we've got the added aspect of knowing what a logarithm with different bases looks like. All right, so I have one last thing to mention, and when we take a look at this one, I want to use it to introduce a certain concept. But if you like doing the last step in a different way and just continuing to use the definition of what a logarithm is, just please keep on doing that. But I do need to introduce this certain thing as a concept. And that is that if you have a base and it matches the base of the thing that you're trying to take the logarithm of, then the exponent is just your answer. So for example, the log base 5 of 5 to the third power would be 3. The log base 86 of 86 to the 7th power would be 7. So if you've got the same base as this base, then the exponent equals the answer. Okay? Now, what you can do is you can use that fact as a way of writing something in logarithmic form. So for example, if this is a 5, then you want to do log base 5 to both sides of this equation. And really that's what I wanted to introduce, is that you can take the logarithm of both sides of an equation and still have it be equal, just like you can add, subtract, multiply, or divide. You can choose your base strategically. So if I wanted to get rid of this 5, I can do a log base 5. And this is really the concept that I wanted to introduce to you. So if I do log base 5 to both sides of this equation, okay, 5 log base 5 of 5 to the third power is 3, based on this idea. And then this is just the rewrite of that. So here we have what we did in the other way. Okay. log base 5 of 125 equals 3. And that's how we had done it before, but we hadn't done it by applying a log to both sides. So this is the thing that I'm introducing to you. But if you still want to look at this and say, oh, that's just log base 5 of 125 equals 3, please keep doing that, because I don't really want to confuse it, but I did need to throw in this little bit about being able to take the log of both sides, because that's going to be important slightly down the road here. So this takes us to the end of section 2. Do please make sure that you fill out the form and ask your questions. We do have a open notes where you are encouraged to call each other quiz on Thursday. Tomorrow we're doing section 4, which will not be on, or the first part of section 4, which will not be on the quiz. And the lesson that we have tomorrow, you're just going to be responsible for watching the video tomorrow on that, but the homework for it won't be due until Monday. So just kind of keep that in the back of your mind, that tomorrow, yes, you're watching a video and it won't be super long. And yes, you're giving a little feedback on that, but the most important thing will be giving feedback on assignment 92 and also anything that you have questions on. And I'll produce a little question answering video also for those that need it, and you're able to skim through those just on the things that you have need of. All right, so there's that, and I hope that you have a really good day today, and I am continuing to pray for the things that you have asked me to pray about. All right, God bless you.